In this section, we're going to discuss solution dilution. We know that solutions are often stored in concentrated forms called stock solutions because we have limited space in our laboratory, right? But a lot of times lab procedures call for less concentrated solutions. So we need to take the stock solution and dilute it with water in order to get the required concentration. We first add a certain amount of stock solution and then we dilute it with water. But the question is, how do we know how much stock solution to add and how much water to add to it? Well, we use this equation, M1 V1 is equal to M2 V2. Here, M1 is the molarity of our desired concentration, which is 1.50 molar. And our volume 1 is going to be the volume of our desired compound. So our M2 then is going to be the molarity of our stock solution, which is 12.0 molar, and volume 2 is what we're trying to solve. So let's solve for this equation. It looks like we need to solve for V2, and we can simply do that by dividing M2 on both sides. So V2 becomes M1 times V1 over M2. So 1.50 molar times V1, which is 500 liters, divided by our stock solution molarity, gives us 0.625 liters of 12.0 molar solution. Or this is our stock solution, okay? So what does this really actually mean in the laboratory? I would have to take my 12 molar stock solution, my highly concentrated solution, and I figured out from this equation that I need 0.625 liters of that. So I take 0.625 liters of stock solution and I add it here. So 0.625 liters of 12 molar stock. Okay, once I've added that in there, I need to add my water, and I'll add water till the 5-liter mark because I need 5 liters. Now the solution concentration that's in here is going to be 1.5 molar, exactly as I have requested. So I need 5 liters of 1.5 molar concentration. I simply take 0.625 liters of my concentrated solution, my 12 molar solution. I add it to volumetric flask, and then I dilute it to the 5 ml or 5 liter mark. Okay, now you go ahead and you give this a try. How much 6 molar sodium nitrate solution should you use to make 0.585 liters of 1.2 molar sodium nitrate solution? Okay. So let's identify my variables here. It looks like my volume 1 is going to be 0.585 liters. My concentration, the molarity of my solution that I need is going to be 1.2 molar. It looks like I need to figure out how much I need to add my volume 2, and the molarity of my stock solution is 6 molar. Okay, so how much of my stock solution do I need to add to my volumetric flask in order to get that 1.2 molar solution that I'm looking for? Let us solve for this using M1 V1 is equal to M2 V2. Here V2 would then be M1 V1 divided by M2. So M1 is 1.2 molar times V1, which is 5.85 liters. divided by M2, which is 6 molar. That's my stock solution. It's highly concentrated solution compared to the 1.2 molar. And so what do I get? I get 0.117 liters, or for significant figures, 0.12 liters. What does that mean? I need to add 0.12 liters of my stock solution, of my 6 molar solution here, and then I'm going to fill it with water up to the 0.585 liter mark in order to get a solution with a concentration of 1.2 molar. Okay? We've previously talked about stoichiometry in the last unit, in which we had a grams of product or reactant, and we used it to figure out the grams or the moles of another product or another reactant needed for the reaction. But a lot of times we are using aqueous reactants and products, and these aqueous solutions, remember, are as anything in water. So it's often more convenient for us to specify the amount of reactant or product in terms of their volume and their concentration as opposed to their gram values. Because you just try to relate this to the laboratory, we're working with this stuff and that exists in aqueous solution in the liquid form, not the solid form. So we can use volume concentrations to calculate the number of moles of products or reactants, and then use the stoichiometric coefficients to convert other quantities in that reaction. Let me explain to you how we do that by this example. How much 0.125 molar sodium hydroxide solution do we need to completely neutralize 0.225 liters of 1.75 molar sulfuric acid solution? So let's write everything down here. This is got to be liters, and it's got a concentration like so, and we are looking for the volume of this of sodium hydroxide, and its concentration is 1.25 molar. Now you probably say, okay, fine, use M1 times V1 is equal to M2 times V2. The only problem is we could only use that equation if we had a 1-to-1 ratio of moles. Here you can see that according to my reaction, for every 1 mole of sulfuric acid, I need 2 moles of sodium hydroxide to react it with. So how do I get this going? I begin with my volume here. Okay? So if I have 0.225 liters of H2SO4, and I have its concentration here of 0.175 molar, remember, what does concentration mean? Okay, the molarity is defined as the moles per liter of something. If I have liters and I have moles per liter, then I can go from liters to moles. Then I can use my balanced chemical equation to, because this is a ratio saying 1 mole of sulfuric acid needs 2 moles of sodium hydroxide, okay? So let me use my molarity as the conversion factor now. So, for every 1 liter of sulfuric acid, I have 0.175 moles by definition from its molarity here, okay? Now I can use my balanced chemical equation. For every 1 mole of H2SO4, I have 2 moles of NaOH, or sodium hydroxide. I'm not done yet because I'm being asked how much of this solution in terms of volume, because this is an aqueous solution. Well, I have the molarity here. The molarity is telling me that for every 0.125 moles of NaOH, I have 1 liter of NaOH. Okay, so I can use that as a conversion factor. Since moles is on the top here, I'm going to put moles of NaOH on the bottom and liters of NaOH on the top. For every 1 liter, I have 0.125 moles of NaOH. Okay, so you can go ahead and figure out the math right there, and you will find an answer of 0.630 liters of NaOH. So you need this much, 0.630 liters of sodium hydroxide in order to neutralize that much sulfuric acid, in order to neutralize 0.225 liters of sulfuric acid. And this is something that you'll do in general chemistry, in which you will be working with acids and bases and neutralizing them, and what we call titrations, but you'll get to that later. The main point that you want to take away from there is that since we're dealing with reactants that are in the aqueous solution, and so they exist in water, it's more convenient to represent their amount in terms of molarity, which is concentration, and volume. Okay, now you go ahead and give this a try. How many milliliters of 0.112 molar sodium carbonate will completely react with 27 mils of 0.135 molar nitric acid according to the reaction? Okay, so let's write everything, our values down. We have 27.2 mils of nitric acid with a concentration of 0.135 molar. And then we are trying to figure out how many mils of sodium carbonate we're going to need to react this much. And our concentration of this is 0.112 molar. Okay, so of course we cannot just use M1 times V1 is equal to M2 times V2, because we have to take into consideration the stoichiometry of this reaction. So we're going to set it up using dimensional analysis to make things easier for us. Okay, so we have 27.2 mils of HNO3. Then we are going to use the molarity as our conversion factor, because molarity is moles per liter. But I just said we have a conversion factor of between moles and liters, but our value is in milliliters. So let's go ahead and convert this into liters in order to use this conversion factor. So for every 1,000 mils, I have 1 liter. Now I can use my concentration, my molarity, to figure this out. So I know that for every 1 liter, I have 0.135 moles of HNO3. Now, I can use the stoichiometry here. For every 2 moles of HNO3 that I have, I need to consume 1 mole of sodium carbonate. Okay. Finally, I can't stop here because I'm not being asked how many moles of sodium carbonate that I have. I'm being asked how many milliliters I have. I can use the concentration of this as my conversion factor. I know this is, again, molarity, and so this is saying for every 1.2 or 112 moles, I have 1 liter of sodium carbonate. So, with that being said, since moles is on the top here, I'm going to put it on the bottom, and liters is on the top. And for every 0.112 moles, I have 1 liter of sodium carbonate. can I stop there, or in that case I need to go back and read the question. It says, how many milliliters do I need? So I can just convert this back. But notice when I do that, I can simplify the math. I just showed you this as an extra step, converting to liters, because I wanted you to see how we take into account these units. But since 10 to the third is on the top and 10 to the third is on the bottom, I can just cancel those out. And go ahead and multiply the rest of this out. I get 16.4 mils of sodium carbonate. So I need 16.4 milliliters of sodium carbonate in order to neutralize 27.2 mils of acid with the respective concentrations that are mentioned in this problem. Go ahead and do more example problems on this so you may get comfortable with it.